Hey, AP Chemsters, this is Mrs. Vanderwall bringing you the second part of 16.2 video. This is a super duper part, important part. So if you need to take a stretch, do some jumping jacks, and get ready for another thrilling edition, go for it. So anyway, we're going to continue our discussion on buffers. Jonathan, I said buffers. I didn't say zebras. I said buffers. Go away. All right, so we're doing buffer. Sorry about that. And anyway, let's recall what a buffer is. A buffer is a system of a weak acid and its conjugate base, or the base and its conjugate acid, and it is going to resist changes in pH with an additional amount of acid or base added to it. So if I put sodium hydroxide in or hydrochloric acid in, the pH will not change very much, okay? It does say it will change by a small amount, but not by much. Now keep in mind, what are we doing? First thing we're going to do is add an acid or base. So what is that going to conjure up if we're going to add something? Hopefully stoichiometry. And the stoichiometry recalls using a BCA table. And once that stoichiometry is done and you subtract it from one side and add it to the other side, now we have a new system which will have to achieve equilibrium again. Do you remember what Le Chatelier said? How can the equilibrium be shifted? Well, if you change the concentrations of one or the other. If you add an acid or a base to this system, this equilibrium system of a weak acid and its conjugate base, you're going to shift the equilibrium, and so you have to set up the ICE table again, or we now understand we have to use the HH. So the first step is to use your BCA table and see how that shift is going to work, and then we're going to use the equilibrium idea to figure out what our final answer is. What is our final pH, okay? Now, why do I bring back the idea of the BCA table? Do you remember what unit a BCA table always had to be in? It was always in the mole. Not molarity, moles. And equilibrium, or the HH, what do we use there? We use molarity. Please keep those two units separated in your mind. Keep these two parts separated in your mind. Every one of these will have to have two parts. Number one, step one is stoichiometry. Part two is the equilibrium calculations, okay? Very important. So let's check this out. For example, a 1 liter buffer solution. Why do I have to worry about liters? Because you have to worry about moles. Contains a 0.100 molar of the generic acid HA and 0.100 molar of its conjugate base A minus. Calculate the pH of the solution before and after 0.025 moles of a strong acid H plus, like hydrochloric acid, nitric acid, whatever. For now, volume is negligible. So again, let's assume the Ka is 1 times 10 to the negative fifth. Okay. Well, let's first of all, before, because remember, look up here, calculate the pH of the solution before and after adding. So let's look at the pH of the solution before. Okay. We're not adding anything. There's no stoichiometry. All we have is a weak acid and its conjugate base is in an equilibrium system. So we don't need two steps. You only need one step because you're not adding anything yet. Okay, so what are you going to use? You can use the ICE table or the HH equation, the Henderson-Hasselbalch equation. I don't know about you, but I think the Henderson-Hasselbalch equation is a little bit more elegant, okay? A lot less time consuming. And it is, after all, on your equation sheet, so there's not even something to memorize. So my work is going to be done using the Henderson-Hasselbalch equation. If you want to do ICE, go right ahead, okay? So let's use the Henderson-Hasselbalch, okay? There's my formula. As always, write down your formula. And now what? We need to know what pKa is. Well, I made it easy for you. Look at that. What's the pKa of 1 times 10 to the negative 5? It's a 5. So here, oops, wrong one. There we go. So here's your pKa right here. And notice we have these equal amounts, okay? The ratios are the same. And so what's 0.1 divided by 0.1? 1. So it's a log of 1, 0, and there we go. So the pH before we do anything, sorry about that, is going to be 5. Keep that in mind, because now we're going to add some acid, and let's see how the pH is going to change. Now, do you expect the pH to go up or down? Hopefully you said down, because we're adding in acids, become a little more acidic. But how much down are we going to make it? Okay, how much will this change? That's the question. So let's see what happens. What's the pH? Come on down. Why aren't you scrolling down? Hang on. Oh, it helps if you do the right thing here. All right, so we're going to do the pH after the addition. So how do we begin? Well, this is what you got to think about. This is what you got to ask yourself. What will the acid react with? Well, what acid is that? Oh, let's scroll back up again. What acid is that? This acid. What will the strong acid H+, which is hydrochloric or nitric or whatever, what will the hydrochloric acid react with? You have two choices. It's either going to react with the generic acid, HA, or its conjugate base, A-. So what do you think it's going to react with? It's going to react with the base. So that's what you're doing right here. That is the question you must think about. So here is the new strong acid that you're adding. Here is your conjugate base, and it's going to together form the weak acid. Notice it's a single arrow. Why is it a single arrow? Because it's going to go to completion. Okay, so let's see here. I need some numbers here. Well, what is my initial amount? Well, if we're talking stoichiometry, we don't call it initial, we call it before. So if you recall, we have 0.1 molar of each solution, but folks, this is not molarity. This is moles. And what is moles equal to? It's equal to molarity times liters. That's why we had to know it's in a 1 liter container. So you take your 0.1 molar times your 1 liter, and this is 0.100 moles. 0.100 moles. If you want to squeeze that in when you're writing, be my guest. I can't fit that in typing, all right? And so that's my before. This is before I do anything. Now, when I do this kind of a problem, this next step isn't really a B, it's not really a C, I don't know really what to call it, but I'm going to stick it kind of like underneath the B, because this is where I'm adding the 0.025 moles of my acid. Okay, so this is my initial, this is my beginning initial step, and now I'm going to add this part here. And what's going to happen? Well, all of that H+ is going to be reacting with the A- to make the weak acid. So notice minus, minus, plus. Do you see that? And so what's going to happen with your amount of acid? Your amount of acid gets totally used up. And now I'm going to subtract these two quantities, and I'm going to add these two quantities here. And so hopefully if you do your math right, this is what you get. So 0 moles left over of the H+, is all used up by your weak base, or your conjugate base. And here is how many moles, notice I have moles again, of the conjugate base, and this is how many moles of your acid I have. So now what? Now we have an ice table. And this is where we're now in equilibrium. So this is my new beginning situation here. Hang on for a second. I retyped this so it looks a little bit like what we're quite used to. I put the water in it instead of leaving like this. I have the hydronium ion. And now what? Well, what is my initial condition of A-? It's 0.075 moles, but wait a minute. What goes in the ice table? It is molarity. I need to find the molarity of everything. Well, fortunately for us, the math is pretty darn easy. Your concentration of a negative 0.075 molar, H3O plus was all used up to begin with. We are going to create some more, but the initial addition of your strong acid, you use it all up. Okay, so these are my initial conditions now. Do I have to fill out the ice table at this point? No, you don't. You can use the Henderson-Hasselbalch equation. But I like at least setting this part up so I can see exactly what the molarities are of everything. So again, let me show you this. The HA goes there, and the A minus goes right here. So I went from moles to molarity because my volume is 1, and that's where I got these numbers for part 2. Okay, so let's use the Henderson-Hasselbalch. Here's my equation, which I always encourage you guys to look at or to write down. And then I found, here's my pKa. Notice it didn't change. But what changed this time? These numbers changed, okay? So it's my base over my acid. Here's my base over my acid. And what is 0.075 divided by 0.125? I know it's less than 1, which should start like going ding, 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 ding. So what's going on there? So hopefully you are using your calculator. And what is 0.075 divided by 0.125? Did you get 0.6? Okay, and this is less than 1. So what kind of a number should I expect this term here to be? I should expect it to be a negative number, which indeed it is. And if you do the math, you got 4.78. So what was our prediction? You remember that? We said that with the addition of the acid, I expect it to become more acidic. But look at this number here. Did it change by that much? No, it did not. It did not change by that much. So the pH did budge, but not like what it would have been without that buffer system in there. Okay, so let's see what happens next. So what's happening here? We are adding base to this buffer system, calculate pH. And what was that question I wanted you to ask yourself? Because this is the question that you will answer to see what your first step is. The question is, what will this base react with? Will it react with the weak acid, or will it react with its conjugate base? And I wrote, this is your equation for the BCA table. So step 1 is the BCA. So answer the question now. What will the base react with? If you said this, actually I'm going to go over here. If you said this, you are correct. It's going to react with the weak acid, and you are going to make water and your weak conjugate base. And so let's go back, and our initial setup is about right like this. Okay, I have initially 0.100 moles of my weak acid and 0.100 moles of my A minus. And now, remember what I did last time? This is not really my beginning, but it's sort of my beginning. So I've established my buffer. This is the true beginning. And now what is this step showing you? It's showing you the addition of the hydroxide. And now what? It's going to react with your weak acid and go over here. So here's your change. All of that's going to get used up. And now I'm going to be subtracting and adding. And here is my after. Notice that my base gets totally used up. I get less of my weak acid and more of my conjugate base. So that's my step 1. What's my step 2? I have to come up with the ice table. So once again, let's scroll back up here. What were we given? We were given this acid and base setup, and we're given the Ka. So how should I set up my ice table here? And folks, trust me, I've been doing this for a long time, as you well know, and I know what kind of questions and what kind of hang-ups students have. And it's like, well, holy cow, what's on the reactant side? We have all this stuff floating around. Well, not quite. We have a weak acid and its conjugate base. That's all we have right now, and some water, which doesn't really count. So what do you write down first? Well, you have a Ka, write it down first. So here's my weak acid. Now I don't have any base left over, it's gone, so it has water there, and I'm going to make hydronium ion and the A minus. So I need to go back in my initial setup. Now look what I've just done here. Here's my weak acid, there's my molarity. Here's my weak base, here is the conjugate base, there is its molarity. So I use the moles divided by 1 liter, and there's my molarity. What can I set up next? I can set up you can do ice, or you can do the HH. You know what I'm going to do. I'm going to do the HH. Okay, so here it is. Once again, pKa is 5, And now look, here's my base. Let me use maybe a different color. How about green? I feel like green today, even though it's not Christmas. All right, and here's my acid. And notice those get put where they need to go. And now it's just a matter of plug and chug. Now wait a minute. What is this ratio? Is this ratio greater than 1 or less than 1? Yes, it's greater than 1. Okay, it's 1.67 to be exact. Now what I think is so cool is, remember what we subtracted last time by? Let's kind of see what we subtracted last time by 0.22. Well, you know what we're doing this time? We are adding 0.22. And there's my pH. Does this make sense to you? Always ask yourself that. Does this make sense? And I sure hope you get yes. If not, write down a question and ask me later. Why does this make sense? Well, Mrs. Vandeloy, yeah, why is that? Because you're adding base. See this? You're adding a base to the system. So what should you expect your pH to do? Go up. Okay, let's keep going. All right, problem 5A. Why don't you pause this and do letter A all by yourself? Oh, make sure to write small. Now pause this. Okay, hopefully you're back. And how did you begin? What equation did you write down? Well, what is this? This is a Ka. So what do you write down on your reactant side? Write down the acid on the reactant side. There you go. And now what we have, this is before you do anything, so you are looking at just the initial setup. I did tell you to write small, right? So again, we're not adding anything. No acid's been adding, no base has been adding. So what can you use? You can just use the Henderson-Hasselbalch equation, okay? And now let's just plug in some numbers. And notice that we can put in the initial concentrations. Well, hey, what do you know about this number right here? What is this divided by this? It's going to be 1. So the log of 1. And what is the log of 1? It is 0. So the pH is equal to pKa, and that's 4.7. Now, here's part B. What are you doing in part B? Think about it. Think about the question I told you to think about, and go ahead and solve this. Remember, 2 steps. Pause this and go. Okay, hopefully you figured it out. The question that I wanted you to ask yourself is, in part B, what will the solid sodium hydroxide react with? The acetic acid or the acetate? And what did you guys get? Let's hope you got with the acetic acid. So here is this is going to be your BCA table, okay? And so what is the real beginning? It's right here. I don't have any hydroxide to start with. I do have some acetic acid and some acetate. And now what? Remember what happens here. So it's not really a another B step. It's just sort of. This is my initial conditions. This is my true beginning. This is where I just have the buffer, but now I'm going to add 0.10 moles. And now what's going to happen here? I think you're going to realize that we're going to have a change. We're going to use up all the moles of hydroxide, and we're going to subtract here and add here. So here is my A value. Okay, so that's my step 1. Okay, is the BCA table. I guess I'll stick it right here. So now what? I need a step 2, don't I? So step 2 is what? What do I start with? Well, what did we have here? Remember, we have a Ka. So I would put the acid as the, I'm running out of room here, as the reactant. I'm going to kind of scooch stuff over, I guess. And your weak conjugate or your conjugate base as your product. Okay. Now using these numbers here and here, and remember we're in a 1 liter solution again. That's where my molarity comes in. That's my molarity. And now we can use my favorite Henderson-Hasselbalch equation. And notice I used the same pH as before, but what happened here? I don't have the same amounts anymore, do I? So my base over my acid. Now look at this ratio. It is greater than 1, isn't it? All right, so I would get log of 1.22, which is a positive number, And that should give me then my pH. Okay, notice my pH went up. Why? Because I added a base. And now letter C is calculate the pH after adding 0.10 moles of solid sodium hydroxide to what? No buffer. No buffer. So over here, I just said assume 1 liter. So then the molarity will equal to 0.01 molar of your base. So your POH is equal to 2. So your pH is 12. So folks, with a buffer, here's your pH. Without a buffer, here's your pH. That's pretty significant, isn't it? Why did that happen? Because your weak acid was there to neutralize any additional base. So without that weak acid, it's going to skyrocket to 12. Very, very basic solution. But with the buffer, it remains a fairly, much safer quantity than pH of 12, okay? So let's see what section, or excuse me, what problem 5B is saying. Well, what's different in 5B? So why is this problem 5B? Well, it's the same setup as before, but this time, what am I adding? I'm adding some acid. So what question are you going to ask yourself? That is the first step. I'm sorry, that you have to ask yourself that in order to go on. Did you ask yourself what will the hydrochloric acid react with? It's either going to react with the acetic acid or the acetate ion. And what is the answer to that? Is an acid going to react with the acid? No, it's going to react with its conjugate base. So this is your first equation. We go ahead and do step 1 and finish this off. Pause this. All right, see how you did. Oops, I kind of lost that. Nope, come back here. All right, fortunately, Jonathan didn't show up in the meantime. Okay, so here we go. Here's my moles. Again, why are they moles? Because I have a 1 liter. And now what? Here is my second little addition here. I am now adding the hydrochloric acid. So what's going to happen? It's going to get all used up. And so I'm going to subtract, and add. And when we're all set, here is our final amount. We have no more of the HCl left, but we have used up all of the acetate, or we still have some acetate left over, and we have made an additional amount of acetic acid. So now my step 2, whoops, little thingy here is says step 2. And again, what are you going to write down first? You have either the acid, should you write the acetate ion down? You know, you really could, but I don't recommend it. You have a lot more work to do. Or you can start off using this. Why would I start off using this? Because what was given to you? Ka. Okay. And now we have new molarities. Okay. Again, where those numbers come from, here is your acid. Here is your base. I divided moles by liters and got my new molarity. What do you think I'm going to use next? My favorite HH equation. I guess I'll stick it right here. Notice my pKa is still the same. This time I put my base on top of my acid. Okay, and look what number, what's that ratio going to be? That log is going to be less than 1, so log of 0.82. And when you do the math, this is what you get. And notice with the addition of an acid, it became a little bit more acidic. But do you think that that's really changed a lot if I just put hydrochloric acid in pure water without a buffer? Holy cow, that pH is 2. So this didn't change it that much, considering without the buffer, the pH is 2. All right, let's check out next one, problem number 6. All right, you work on this one and see what you get. Okay, so hopefully you're able to do a little bit of smarts and cancel out these two, because that's kind of a big jump from 5.25. So I hope that you figured out that if you add acid, what's going to happen to pH if you add acid to it? You're going to get small amounts of acid. You're going to lower the pH, so your answer is B. Okay, so what's different about this one? Well, if you notice, buffers contain a base and its conjugate acid. So up until now, we've been having acids and conjugate bases. This time I have a base and a conjugate acid. Again, you must contain significant amounts of its base and conjugate acid. Probably the most common one would be this. It's not the only one, most common one. Be careful when using the Henderson-Hasselbalch equation. Here you go there. Same equation, but I said be careful. Why? Because if you're talking about a base, what do you think they're going to give you? They're not going to give you Ka. They're going to give you Kb. So you need to solve for Kb this time. And lo and behold, it's pretty easy to do. You just subtract from 14 and voila. So problem 7a, calculate the pH of a buffer solution that's 0.5 molar in ammonia and 0.20 molar in ammonium chloride. Again, chloride is going to be just a spectator ion. It doesn't do anything about the acidity or basicity of the solution. All right, so here is, what should you do first? Yes, you got it. Write down the equation. Write it down. Why don't you pause this and work it through? You don't need me. Okay, let me just kind of throw you some numbers here. So I had to first find Kb. So once I found I found Ka. So once I found K, which is 9.25, then I just plugged in my base over my acid. So here we go, and pH is 9.65. Hopefully that makes sense to you, because we do know ammonia is a base and this number is basic. So my Kb is a stronger Kb, if you will, is a bigger number than my Ka, and so the whole solution is more, more basic. Okay, so now what? The next question is, all right, so now we know that the pH is going to change because I'm going to add some solid sodium hydroxide. So you know the drill. What question am I going to ask you? Hopefully that's the question I'm going to ask you. So what will the sodium hydroxide react with, the ammonia or the ammonium? So do you think the base is going to react with the base, or is the base going to react with the acid? Well, congratulations. If you said it's going to react with the acid, you got it. So step one, actually, let me kind of go like this, is doing the stoichiometry. And so what do you know about this? If you look, what was our original amount? Oh, let's look up here. 0.5 molar of ammonia and 0.2 molar of ammonium. So those numbers are going to translate, because I have a 1 liter, so 1 liter solution is 0.2 moles and 0.5 moles. But now what am I going to do? I'm going to add 0.1 molar of sodium hydroxide. And why solid? Because hopefully then the volume change is negligible, so I don't have to worry about that like I did with that one problem earlier. And so what's going to happen now? We're going to use up all the sodium hydroxide, and we're going to also lose some of the ammonium, and we're going to gain some ammonia. Okay, and so when we're all done, there we go. So what's my step two? As you know, step two is my equilibrium. Now, what was given to you? Go back up here again. What's given to you? Here we go. Here is my ammonia, and I was given pKb, base. So what should be my reactant? Hopefully you know it's the ammonia. So let's do that. Let's make the ammonia my reactant. So here I go. Oops. And let me put NH, come here. Why are you not working? Oh, because I locked it. Hang on. All right, that works better. And so here's my ammonia and water. Oops, I lost my arrow. Actually, this shouldn't be an arrow. This should be a double arrow. I locked it too. This should be a double arrow. And I don't know what happened to it. So there's my double arrow. And now what? Let's go ahead and use these values here. Notice, here is my base, and here is my acid. If you will, I can draw these little lines again. So here's my base, and here is my acid. Now, again, why are the molarities not different? Because the volume is still 1 liter. Okay, and what do you think I use? Ice table or Henderson-Hasselbalch? Take your wild stab. Yeah, you got it. Okay, here it is. Same pKa before. Remember they gave us pKb. This is pKa. and base over acid. But wait a minute, look at the base here. Here's my base over my acid, okay? And now what? Notice that the value is 6, so that ratio is greater than 1. So I'm going to add a positive number to this, and I get 10.3. Now again, does this answer make sense? Hopefully you said yes, because what am I doing? I'm adding a base, so this number became a little bit more basic, okay? So that number went up. So go ahead and do problem number 7 all by yourself. See how you do. Pause this. Okay, welcome back. Hopefully you got an answer that makes sense to you. There's a teeny tiny twist to this. Hopefully you caught that. So again, the question is, what will the hydrochloric acid react with? Ammonia or ammonium. So step 1 is making that decision. And hopefully you got this. You decided to make the hydrochloric acid react with the ammonia. Make ammonium and chloride. As you know, chloride is a spectator, doesn't do anything. And here are my initial amounts. But wait a minute, what do I do with this 30 mils of a 1 molar solution? Did you know what the new molarity is? It's not 30. Hopefully you got it was a 3, or excuse me, 0.03. So that's what, in a sense, we are adding now. So here we're going to subtract the 2, and there we go. Now, we have a little problem. What's my problem? What am I doing to the volume? Is the volume 1 liter anymore? No. So these are not my molarities anymore. All right, why not? Because molarity is moles per liter, but the volume changed. I don't have 1 liter. I have 1.03 liters. It changed a little bit, okay? And so now the volume, or excuse me, molarity of ammonia is 0.47 moles per 1.03 to get 0.046. So my molarity went down. Same thing here. My moles per liter, my liters increased because I added 30 milliliters, because remember, it's solution. What's in the solution? My original buffer, now 30 mils of HCl. So those are my new molarities. So now we can go ahead and do step 2. It's a little bit of a trick, wasn't it? That wasn't very nice of me. And here we set it up again. And notice, oh, I'm missing my double arrow. Notice that again, I'm going to start out with ammonia because I started out with Kb. And here is my row. I switched one number, not the other. Will you please make this 0.46? I thought I made that change. I did not. And I'm going to use the Henderson-Hassel bucket once again. Here I made all that big deal about making it a new molarity, but I didn't change it. I am so sorry. Make this 0.46. And then when you do this, and again, these are the numbers that you might just get. Let me just see real fast with this. 0.46 divided by 0.22, and you get 2.09. Let's take the log of that. 0.32. Oh, it changed. This should be a 7 instead of an 8, it looks like. So, all right, I'm off by just a tad, and I'm really sorry about that. So this really should be 9.57. You worked it through. All right, one last problem to do, and then we're done, I promise. All right, this should be just a nice review of what we've done. So why don't you go ahead and solve for the problem? Okay, very straightforward. Pause this, and when you're done, come back. All right, how'd you do? Well, of course, the first step is what will the hydrochloric acid react with? And it's going to react with the base. So here's my work. Hopefully I didn't make any boo-boos. I hate it when I make boo-boos. Oh, this is a little bit off. There we go. And then your step 2 is taking your molarity. Now, is gaseous hydrochloric acid going to take much volume? Not at all. So there is my molarities. All right, notice it's still in a 1 liter container. Okay, this should be a +50, sorry about that. And then you just go ahead and use these numbers, and there you go. Hopefully that's what you got. I'm sorry I took up so much of your time. This is truly a very, very important section. So my goal is that we're going to be just working on problems in class next time we meet. Thank you for your patience. Take care.